Hi, my name is Dr. Scott Simpson, and today we'll be talking about the relationship between the freezing point depression and molecular mass. So we know when we add a solute particles or a set of solute particles to a solution, the freezing point of that solution decreases. The boiling point will elevate. We know that the following formula is followed. We have delta TF, the change in the freezing point, is equal to Kf times M solute. Kf is what's known as the freezing point depression constant, and that changes depending on the solvent that you have. So this is the freezing point depression constant. And M solute, that's the molality of the solute. Okay, so how do we calculate molality? So molality of a solute particle is equal to the moles of that solute particle divided by kilograms solvent. Okay, so what we can do is we can find a relationship between these two equations. We're trying to get to a molecular mass. If we plug this in for molality of solute, our delta TF formula becomes a little more complicated, but we're getting closer to finding molecular mass in here. Times our mole of solute divided by kilogram solvent. Okay, so now you know from first semester general chemistry, if you want to find the moles of any compound, what you have to do is take the grams of that compound and divide by the molecular mass. So this big M here, this is molecular mass. Okay, so now we have that, we can plug this back into this equation. And what we result in is delta TF is equal to Kf times our grams of solute divided by kilograms solvent times our molecular mass of our solute. Okay, so we have this as an expression. Most of the time we measured this, we can look this value up. We can measure the grams of solute and we can measure the kilograms of solvent. So we want to manipulate this equation around to solve for M. So our molecular mass of solute is equal to Kf times grams solute divided by kilograms solvent times the change in the freezing point. So let's look at an example utilizing this equation. Okay, so the freezing point depression constant of naphthalene is 6.90 degrees C per molal. 14.5 grams of unknown solute is added to 25.0 grams of naphthalene. And the freezing point decreases by 4.34 degrees C. We want to calculate the molecular mass of the solute. Okay, so let's take the approach. Let's underline what we're looking for. We're looking for molecular mass solute. Let's box important information. We know that the freezing point decreases by that many degrees C. We have that many kilograms of solute, this many grams of solvent, and our freezing point depression constant is that value. Okay, so now all we have to do is utilize that equation that we previously had. The molecular mass of the solute is equal to the freezing point depression constant times the grams of solute divided by kilogram solvent times delta TF. And luckily, we're given all of these values, so Kf, that would be 6.90 degrees C per molal times the mass of our solute divided by kilograms of solvent. So we got to convert that to kilograms. Just divide by 1,000 to get out of grams into kilograms. And finally, our change in temperature. Okay, so looking at these units, you might notice might not cancel out. We're going to get something weird here. The important thing to remember is molality is reported in mole divided by kilogram. So if we sub that in here, we should be able to solve for our unit. So 6.90 degrees C mole times kilogram up top times 14.5 grams divided by 0.2500 kilograms times 4.34 degrees C. If we look, let's see what units are going to cancel out. Our degrees C will cancel out. Our units of kilograms will cancel out, and we're left over with the units of grams per mole, which is exactly what we want. Okay, manipulating this equation and solving, you should get an answer of 92.2 grams per mole, keeping sig figs in mind. So what we've done today is we've shown a relationship between the freezing point depression and the molecular mass of a solute. If you have any questions or comments, please feel free to leave a comment below or feel free to email me. Thank you. Have a good day.